We'll try one more time. I'll create a new rule from scratch.
That's cool. We get to see how you create a rule.
Copy this.
So that search, you're copying that, well, just like a copy, is that like looking at the messages?
Yeah, and so you can query on specific attributes and values and ranges and things like that if you want. Yeah.
Okay, so you can look at like specific attributes of specific messages.
Yep. Yep. So we're selecting star, everything from data. We're going to write it in, then we're going to add an action. So we've got all kinds of actions that we can do. We put it into the DynamoDB table. We can send a message to the Lambda function. Lambda's compute on demand. You build in 100 millisecond increments. Basically, it spins up a container behind the scenes that runs your code. And then from there, you can access almost any other service. And the services just keep growing and growing that you can do. We'll take it. We'll split our message into DynamoDB table. Serve table. Let's create a different role. That may be the point. This didn't save. There we go.
Man. Said I had a null somewhere.
White space at the end. All right.
Just like you cannot do it with LabVIEW.
So we'll try one more time. Connect. Publishing data. Back over here. Refresh our table. And there we go. We're getting data written in there.
Yay!
Yay. So, sorry for putting you through that.
We learned something. More than jogging, right?
So, is this interesting to anybody?
Are you running this on QBO that are pushing the AWS?
Yep. Yeah, so yeah, the SSL is on RT and on Windows.
You push
everything you sample up to AWS, or do you may have to push some things and then go with others?
I create topics for each type of data packet. So we'll have a topic for like system messages. Right? So yes, I got that command. It'll send a response back. Those kinds of things. But we have it so that every device prefixes the topics that they publish and subscribe to with their serial number, and then we'll have a data topics and a DynamoDB table for that data. We publish up data once every 2 seconds. That gives us, real-time look at what's going on with our systems, and everything's archived. And the best for it. Go ahead.
Sorry for interrupting. How many systems are published out?
Right now we're doing just 2, so we're still building up. But AWS can scale 2,000 systems. So you have account limits for IoT. Now IoT is really cheap. It's $1 per million messages. And then you have a connection fee, and that works out to $1.49 a year for a device. So pretty cheap. And then the rules cost a few pennies. Overall, really, really inexpensive. You do have some limits. You can have a maximum per your account. You can have a maximum of 256 DynamoDB tables. That's the limit. And you can have a maximum of 10,000 simultaneous connections across your account. The good thing is there's no limit to the number of accounts you can just scale your accounts. You put a new account for a new customer, and off and go on.
So you guys are using MQTT in this module here.
Right.
Up in the project, I see you've got a folder that I presume is the RESTful API. Are you using both?
No. I started using REST, and it was such a pain in the butt. There's no LabVIEW tools for doing the signature for signing and those kinds of things. There is now.
Yeah. There's a product on the Tools Network, the iCloud Tools Network.
That came like 2 years after I started.
Oh, you started on it?
Yeah.
Yeah, I told him the same thing, and he's like, I already been doing this for a year. I have all this stuff.
Yeah.
Well, if anybody in the room is interested, the toolkit on Tools Network provides S3, SNS, SQS, and IoT, but it's designed to be a plugin framework because the hard part is all the authentication.
Right.
We take care of that for you in the NI code so that if you decide you come along and you want a DynamoDB API, we didn't provide one, but the infrastructure is there for you to add one, and we've already taken care of a lot of the hard parts.
Right.
So the toolkit on the Tools Network and the source code for it is on GitHub.
Yeah, no, it was a great toolkit. It just came along too late.
Gotcha.
I think, but even so, the toolkit actually relied on some OpenG things. So, still within LabVIEW itself, there's still, a massive security hole with not having these tools that we need to do secure communications. So, I've said it before, and I'm saying it again. There's a gaping hole in LabVIEW.
You're referring to what, like SSL?
Right, TLS and all that. To having all those encryption tools. Yeah, somebody used that. There's another tool on the LabVIEW Tools Network, the encryption compendium, and he wrote a complete tool set around this OpenSSL DLL that ships with LabVIEW. It's 900 pounds or something like that, But those are the tools that should be within LabVIEW.
The SSL TLS gap is one that we're aware of, and definitely are.
Okay. Good. In the meantime. So we are putting together this what my company is developing right now, and so these are devices pushing up data into the cloud, and we're using all serverless technologies within AWS. So using IoT for publishing, subscribing data, DynamoDB for logging data, and then we have an S3 bucket where we have a website hosted. And then we're using MQTT within the web UI to directly subscribe to the data as it's coming in. So this is all event-driven.
So what is like made if there's an AWS like provider tools to make this, or you guys just host it on AWS?
We just host it on AWS,
Okay.
yeah. We have the contractors looking for us. It is JavaScript, HTML. Yeah.
It looks really slick. I like it.
Yeah, that's good.
Data driving from embedded devices. You're pushing up the database.
Yes, yes. Yeah, and it's just in the early stages. We're filling up.
So what we're looking at is the storage levels from a solar.
Right, so we're looking at PV, the frequency. This is all just simulated data right now, but we have multiple data feeds that are coming in on that. Look at. Cool thing about it is we can take, and so right now we're at Fusion. We have 15-minute view. We can do a 30-minute view, and it actually goes back, queries the DynamoDB table, pulls up 30 minutes of data, and then starts to build data to it live.
Tell me something about the account management. You said you can have multiple accounts. Signing a Cirio to a customer's account, something that's embedded into that device, or is that something managed in the cloud?
So
changing that look like?
Well, the certificates that we downloaded are the certificates that go onto the Cirio.
Okay. And that identifies the Cirio's place in the cloud.
Well, that would identify that combined with your policy gives us Cirio permissions to connect to that one endpoint.
Okay, but what assigns that endpoint to an account? Like if you had a Cirio and you're doing prototyping internal and then you want to use it for a customer, do you need to update anything on the Cirio, or do you just go into the web and change its ownership?
You actually have to go onto the device and change the certificates there.
Okay, so changing its policy, changing who owns, what account owns that device, changing that.
You can put the new keys on it and tell it where to go.
Is it possible to have multiple keys that it switches between?
Sure, anything's possible.
Anything's possible. Awesome.
Depends on how much time and how much money you have.
Okay.
Yeah, I mean, we're just, pointing the path to the keys.
So AWS can support multiple keys that are valid at the same time?
Yes, yeah. And I recommend using one unique key per device.
What do you see next?
We're filling this out with AWS and their global infrastructure. We think it's really easy to scale up and build a distributed control system that has global reach. And we think that the architecture that we've come up with is highly scalable. It just relies on unique serial numbers. And the next thing that I have to do is to automate that certificate process, and that's going to take a little bit of doing. But AWS provides lots of great tools, and then there's lots of open source tools that are really good. So we're using the serverless framework. That it's a way to you edit a YAML file that basically scripts your architecture, lays it all out, deploys your Lambda functions, your API gateway functions, and so within 10, 15 minutes, you can have a complete new account spun up with all the services enabled. The one thing it can't do right now is create those IoT rules, the actions for writing them to DynamoDB, but it can create all the tables.
If the application is getting data, it's all written in LabVIEW. And what kind of, what's your fallback when the internet goes down to store or save data? Do you have that, or are you not worried about it?
I'm trying not to be worried about it. Our fallback plan is a 48-hour log of once a minute data.
It's on a local machine?
On the local machine, yeah.
And when you said there was 5 writes a minute for whatever that price was, what is the size of those writes?
It's several tens of kilobytes.
Okay.
Yeah.
I thought you were going to ask him. He was using DQMH.
Oh, I saw that. It's branded all over the.
In case it wasn't subtle enough.
He even mentioned it earlier in the presentation, so.
I see.
I thought you were blessed for that.
Oh, it's better if I can see it than somebody else saying it.
The MQTT API that y'all are using, I downloaded that from like an open source or something like that.
Right, yeah.
And how's that implemented? Is that like DLL files?
No, it's all native LabVIEW.
Really?
Pure-G, yeah.
Okay.
Yeah.
What role does Data I/O play in the overall project?
DAC.io
DAC.io.
released the MQTT.
Okay.
Yeah, and we saw it up on GitHub, and he hadn't put a license out there, so we asked him, so what kind of license are you going to publish it? He said, oh, okay, I'll just do it under MIT license and make it freely available. So we did the same thing for our AWS code.
What's the API look like?
Sorry?
What's the API look like for?
That's kind of ugly. So there's where the code is. So it's the DQMH. So we have a event handling loop, we have a message handling loop, and then at the bottom we have a helper loop. And so the main code is right here. So we start out, we're creating some default topics that we're going to subscribe to heartbeat and command. Here we are, we're doing our connection. And so this is the MQTT connect that we've modified. And deep down in here is the DLL calls. Well, this took a lot of pain to figure out.
Does this work on Linux Arcade as well?
Yes. Yep.
So when you say subscribe, though, are you in LabVIEW just having like a read and it'll give you the latest value, or is that going to like some user event? Or?
It doesn't go to user event. It just is the broker publishes the data down whenever there's new data to a topic that you're subscribed to.
The TCP connection, so we use reading the TCP data.
Yes.
Backing it.
Yep.
What are the DLL calls?
There are two that OpenSSL, DLL that ships with LabVIEW.
Gotcha.
And that DLL works in Linux too.
Yeah. So here if we have a successful connection, then we subscribe to topics, wait a second, and then if there's any kind of errors, then we'll reconnect again. So there's limits on you can only connect no more than once a second, so you gotta wait, retry. And then, so once we've connected, we send an event to the helper loop to start listening, and so start listening, we set our millisecond timeout to 10, and then in the timeout case, just sit here and listen for messages. So we parsing the message by what topic it's coming on, any heartbeat messages. Here's the code. Look at the heartbeat, getting our latency. So pretty simple stuff. And then here's the code for sending a heartbeat. So every 5,000 milliseconds, this will fire, send a heartbeat message. Yeah.
I don't know if your application creates large amounts of data that you don't necessarily want to send in real time, but if it is AWS a good platform for that, or should you go to a different avenue for really large quote unquote data files?
Well, I mean, Netflix streams through AWS. Netflix streams through AWS, so there's different services, Kinesis, those kinds of things that can absorb a lot of data.
What was that one you said?
Kinesis.
Okay.
Another person people send trademark is that on the device for the logging files, you know, you can periodically just dump them on AWS. Not like someone's years. Let me throw a file up on the cloud. I don't want all the data in.
Right.
So yeah, we're using this for performance monitoring, warranty information.
I can see where you might want both, right?
Yeah.
What's going on right now.
Right. And so yeah, we can by logging data every 2 seconds, it's plenty fast enough for us, and then make sure that everything goes in DynamoDB, and so we have a historical record to whenever.
Besides the web dashboards, how easy is it to get access to data and so on?
It's pretty simple. So you can create rules that instead of writing it to DynamoDB, it'll dump it directly to S3 if you want to do that. But then you can also just export data, export to CSV.
Out of curiosity, do you have any emergency call people in the middle of the night functionality if the data goes wrong?
No. The good thing is we don't have an IT department. The bad thing is that all we can do is send an email to AWS and
I mean, it's like if your process or whatever you're monitoring goes bad.
Oh, sure. Yeah. Well,
call Joe.
Yeah, we're actually spinning up a monitoring service. Yeah.
Like alarms or something?
Yeah, you can have all kinds of different alarms and processes going on in the background, but we're actually building an operations and maintenance team.
So ever do any controls down to?
We'll put some limited controls in the cloud, but mainly everything will be on the serial because we want it to be in real time. We don't want to depend on connection latencies. So you saw the latency here. We're in under 60 milliseconds, which is okay, but sometimes we'll get 2 seconds of data. Sometimes AWS will decide to close the connection. There's different things like that. So we always want to have our real-time controls going on in real time. We're monitoring that heartbeat latency, so if we lose our connection, then we have some options to fail safe.
What kind of non-real-time controls? Or are you not really?
We're looking at doing more like day-ahead prediction of energy usage, and then being able to load schedules down on too. So. Right, and so we'll create topics. We'll have configuration topics, and so we'll publish the updated configuration changes to the device. It can take those changes in real time and apply them. So we'll have a bunch of different control modes. Maybe we're doing frequency response or voltage response, and following the AGC signal, a power signal from the utility, those kinds of things.
So, is that something you want to do in LabVIEW, or would it be what you do on the web, so the wrong location, not the way I do, and your LabVIEW data?
Yes, and that's what we do.
Okay.
Yep.
All right.
Yeah. Okay, well, no more questions. That's kind of it.